Hey guys, welcome to today's video where we'll be going over solubility. Um, just like the last videos that I've done talking about the gas properties, we'll be doing the same thing here where we'll be talking about solubility, solution, suspension, and all the S words, not the S words that you guys think of, but yes, the S words, solvent, solute, so on and so forth. So let's jump right into it. So in this slide, we have the definition of solubility. What exactly is that? This is the amount of solute that can dissolve in a given solvent. A solute is the minor component that dissolves into a solvent. The solvent is the liquid in which a solute is dissolved to form a solution.
Can you move it along? I'm all out of time card.
Whew, okay, guys, let's get ourselves back because I think that was a lot. And I think the best way to see this is through a picture representation that we have to our left. So right here we have our solute. It is pink, but we're going to say this is like a sugar cube. So that's our solute. That is what is going to be dissolved in a solution or in a solvent. We have our water. And then once you put that solute or that sugar cube into that water, you have your solvent here. It's a mixture. It fully dissolves. So again, solubility is the amount of solute that can dissolve in a given solvent. So this is soluble. It's very soluble because it fully dissolves into the solvent. Now, another thing that we want to talk about is unsaturated solution, saturated solution, and supersaturated solution. Because this ice cube or this sugar cube may not always fully dissolve. So if it doesn't dissolve, it would be considered a saturated solution. A saturated solution says that there's no more solute that can dissolve. So it's just a maximum. The club has reached max occupancy. We can't let any more people in. So this doesn't dissolve. And you can see the same here in the supersaturated solution. It becomes unstable or crystal forms at the bottom. So what you have is something called a precipitate, right? And then at the top, you have the supernatant, and you'll see this a lot in lab practices where you do certain extractions and you want to get at the top layer, which is the supernatant, and you don't want this stuff at the bottom because this is the stuff that doesn't dissolve in the solution. So in this next slide, we have more definitions, a bit of the same thing that I said last slide, but I'll reiterate so it get hammered into you guys' heads so we can then go ahead and do that one practice problem that I have in the back end. So again, a solution, a homogeneous mixture of one or more solutes. Unsaturated solution, the solute readily dissolves. As you guys see here, we have, again, our cool sugar cubes, and it is fully dissolved. The max amount of solute is not reached. We could let more people in the club here with this unsaturated solution. But with the saturated solution, we've reached the maximum amount of solute. There's no more people we could let in this club. See you guys next week. And you guys can see it down here where, again, we have these like sugar cubes, and we could see a precipitate form at the bottom. So it's like this big clump. And the same thing with the supersaturated solution. It just goes towards the bottom. It's like, well, we can't dissolve anymore. We've reached that maximum threshold. So we can't, do this dissolving thing anymore with you guys. You guys just have to go to the bottom, right? All right, so let's get right into the word problem. So it says at 20 degrees Celsius, the solubility of potassium chloride is 34 grams over 100 grams of water. In the laboratory, a student mixes 75 grams of potassium chloride with 200 grams of water at a temperature of 20 degrees Celsius. So the questions that they're asking are, how much of the potassium chloride can dissolve? Is the solution saturated or unsaturated? And what is the mass of any solid potassium chloride on the bottom of the container? Well, first what we want to do is let's dissect the word problem. And this will be talked about in later videos. The temperature is constant. It doesn't affect anything for now. So we don't even have to worry about that part of this word problem. What we want to get down to is how much potassium chloride can dissolve in 200 grams of water. So we already know that 34 grams is dissolved in 100 grams of water. So if you guys already beat me to it, we can just say that since we're asking 200 grams, wouldn't it just double, right? And that is true. So that just means that 68 grams of potassium chloride would be dissolved, because we're saying for every 100 grams, 34 grams is dissolved. So for 200, you would just double it. But of course, this is chemistry, so we have to do a little bit of conversion in math, right? So to do this, we would say we have 34 grams of potassium chloride in 100 grams of water. And what we want to find out is what it would be in 200 grams of water. So we have to do times 200 grams of water. And in your elementary or middle school, whatever grade it was, I can't remember, we cross like units. And if we divide 34 by 100 and times it by 200 on your calculator, you'll get 68 grams of potassium chloride. So that answers the first question. How much of potassium chloride can dissolve? Only 68 grams will dissolve in 200 grams of water. So now if we go to our next question, so this is A. If we go to our next question, is the solution saturated or unsaturated? What do you guys think? So we're saying that in the 200 grams of water, only 68 grams of potassium chloride dissolves. But remember, this student put 75 grams, right? So they student put 75 grams. So this exceeds the amount that the student put. We can only have 68 grams for it to readily dissolve, but the student put 75. So guess what that'll make it? Think. That would make it saturated because it reached the threshold. We told this student, hey, we can only allow 68 grams for it to dissolve. This student didn't listen and they put 75 grams. Again, they put too many people in the club. It reached maximum occupancy. So the answer to B is that it'll be saturated. We can't let any more people in the club. And then lastly, C, it asks, what is the mass of any solid potassium chloride on the bottom of the container? So since we have an excess of potassium chloride, we have 75 grams, and we can only readily dissolve 68. So what does this mean? How much will settle at the bottom? 68 grams is going to readily dissolve. The rest of it, which would be the difference between 75 grams and 68, equals 7 grams. So that means 7 grams will be stuck at the bottom because this student didn't want to listen to the occupancy rule that we had set in place for the club. Okay, so we got answers for all three, and these are some of the simpler questions that you guys will see. But in later videos, we'll go into more depth and consider different, not parameters, different scenarios that include temperature and much more complicated conversions. Okay, so I hope you guys enjoyed this video, and I'll see you guys next time. Peace.